Welcome everyone. Today in this lecture we will be getting some knowledge on PostgreSQL's native backup tool called PG based backup. As I'm mostly into PostgreSQL world and its internals, I wanted to explain about backups and recovery strategies in PostgreSQL. As we already know that PostgreSQL is an open source database and it supports various kind of backup solutions like online backup solutions, online physical backups, advanced backup techniques, and point-in-time recovery for enterprise-grade reliability. In the world of data, we may have experienced these scenarios like hardware failures, data corruptions, user negligence, or software bugs, or any catastrophic damage happen in large data centers. So that is where backup solutions are much needed and plays an important role to bring back our data from any such losses. So getting into PostgreSQL, the internals of PG based backup and currently and the past supported backup types. In the version prior to PG 17, PG based backup only supports file system level full backup and does not support any incremental backup. But starting from PostgreSQL 17, we have the support for incremental backups. In this video, we will discuss the steps to implement full and incremental backup using PG based backup and how PG combined backup is used for merging a full and incremental backup to make a complete restorable backup. So, the need for a good backup strategy. What is the need? Why should we back up our databases? We do backups because of any unforeseen catastrophes or wars that damage our databases or data centers. A strong backup strategy for most of the databases, including PostgreSQL, is required to support the key functionalities like disaster recovery, point-in-time recovery, and replication scenarios for high availability setups. So, what is disaster recovery? We need to recover a database after a total system failure like hardware crashes, fires, natural disasters, or data center outages, and other failures leading to the loss of complete data centers or database systems. So when it comes to the point-in-time recovery, a point-in-time recovery is like rolling back the database to a specific point in time. This helps in scenarios such as accidental drop table, data corruptions, deployment failures yielding to data loss, or other accidental changes. Point in time helps us to take the database back to a healthy state as long as we have a good backup strategy. And also in some replication scenarios like for HS setups, we use the replication for high availability setups, right? So backups are the primary steps to be performed for setting up replication. In order to set up a replica or a standby, we must be able to take a consistent backup of the database that can be restored on the standby before replicating changes from the primary. Now we will see some natively supported tools in PostgreSQL for a strong backup strategy. The three requirements we saw in our last slide should have to be achieved. As we already discussed the PG based backup, which is a lightweight native PostgreSQL tool that supports online physical backups without any downtime. It enables both full and incremental backups, making it ideal for reliable disaster recovery and point-in-time recovery. The PG combined backup is another tool from PostgreSQL community to merge full and incremental backups. We take incremental backups with PG based backup, but an incremental backup on its own is not immediately usable for recovery. While we backed up our databases with PG based backup. To restore, we must first apply all incremental backups in order to the original full backup. For this reason, PostgreSQL has this tool to merge the full and incremental backups as a combined backup. What is wall archiving? PostgreSQL continuously generates write-ahead logs, wall records, to ensure that every change made to the database is securely captured for recovery and replication. Since wall records are recycled once certain thresholds are reached, enabling archiving or continuous archiving is a must to preserve historical transaction logs. How to enable the continuous archiving? By turning on archive mode and configuring an appropriate archive command, PostgreSQL automatically copies these completed wall segments to external or remote storage or the configured wall archive path. This ensures that even after hardware failures or data corruptions, the database can be fully restored to a consistent state using the archived walls. For people who are completely new to databases and backups, I'll add some terminology explanation here. What is full backup? A full backup or a base backup is a complete, consistent snapshot of the entire PostgreSQL data directory at a specific point in time. It serves as the foundation for any recovery operation. When using PG based backup, the full backup is the starting point for all subsequent incremental backups. Now, incremental backup. An incremental backup captures only the blocks or files that have changed since the last backup, which could be the full backup or a previous incremental backup. This reduces backup time, IO load on the server, and storage space compared to running full backups daily. Now we'll have some steps to set up full and incremental backup using PG based backup and PG combined backup. There are some prerequisites, settings to be changed inside PostgreSQL to get the state of a data directory or database wall level. This should be at least be set to replica. This is the default. Also there are logical and minimal as options. We may use minimal instead of replica for full backups, but it won't support wall archiving for point-in-time recovery. Logical is the higher one with some more level of information about the changed blocks in walls, used for logical decoding for continuous streaming of data changes like Debian or any CDC replicator. Summarize wall. This is introduced in PG17 and later version. This must be set to on. Wall summarizer tracks changes at the block level to support incremental backups. This is applicable for PostgreSQL 17 and 18 releases only. The archive mode must be set to on to support wall archiving and point-in-time recovery. When this is set, all wall files will move to the archive location configured in the archive command. Archive command is a shell command or a script to archive a wall. We can use alter system to modify the above parameters. Depending on the parameters being modified, you may need to have a restart or reload the PostgreSQL. You can add them to the PostgreSQL auto.conf. Now we'll discuss the command to initiate a full backup for this. So the command would be like the below. You may have the hostname and port and the location of the backup as per your instance configuration. Here the -h stands for the host. You can add your remote data directory IP here. -d refers to the place where your backup should be put. -b gives us the progress percentage of what extent the backup has been completed. And the -v gives us the detailed verbose logs for debugging any middle failures that happened. And the -x with the s option used to stream walls to be included in the backup file while backup is in progress. We also have -f options with the -x such that it fetches all the wall files after the backup is completed. One has to prefer going with -x option alone. So there are things that has to be remembered before taking a backup. The backup should be taken with a super user or a user with replication role. The PG based backup by default creates a manifest file unless --no manifest is applied to the command. This manifest file consists the list of every file present in the backup with the exception of any wall files that may be included. This is needed as a reference for the incremental backups to maintain a relationship for later backups. And that is how we have a full backup sitting in the location mentioned in -d option. For production safety, run this or schedule this full backup on weekends or any non-business hours so that the IO can be less and does not impact the mission critical workloads. And later we can take incremental backups with the same command, supplying the backup manifest file to the full backup so that the incremental backup can be taken. We'll see the command. So that's the command here. PostgreSQL community now added --incremental option to take incremental backup, which is not present in versions before PostgreSQL 17. The incremental backup needs a backup manifest to create an incremental backup so that it identifies which blocks have changed since last full backup. All the options remains the same as full backup. We just mentioned incremental option and pass the manifest and we'll get an incremental backup. In the scenarios listed above, like under a disaster recovery where we have lost our data or we dropped a table mistakenly and want the table back, we might go with restoring the available backup to a location and take a dump of the table and restore it in the production. This will need a fully restorable backup to get the dropped table back, right? Further, we might need to merge a full backup and an incremental backup using the PG combined backup. The PG combined backup expects the first argument to be a full backup path, followed by the path to n incremental backups. It is to be noted that PG base backup doesn't register each incremental backup with a numbered sequence backup. Using the below command, we merge the full and incremental backups that were taken in the previous step. The first argument would be the path for the full backup, and the subsequent arguments would be the incremental backups, and is followed by with the -o options where the merged backup will sit. Now that we have a merged backup, we will now copy the necessary configuration files to a merged backup folder path. We make the necessary edits to the port and data directory entries and will start the server. Here the configuration files are the pghba.conf file, the postgresql.conf file, postgresql.auto.conf, and pgidentity.conf, and other configurations under the conf.d directory. We might have to move all these files from the primary to the newly restored directory, and we can start the instance using the pgctl command. After starting the database, it will recover all the vaults that are present in the restored pgvault directory and promotes itself as a standalone database, and it is now ready to accept database connections. So this is how a database is fully restored. For a point-in-time recovery, we might need to see the next slide. For point-in-time recovery, or recovering your database just before the table has dropped, we might utilize the archived vaults to restore the database to a point where the table is just one transaction before dropping. For that, we need to do some modifications to recover the database to a consistent point while utilizing the archived vaults. We need to create a recovery.signal file in the recovered data directory to tell PostgreSQL to recover vaults from the vault archive. And additionally, we have to add the parameter restore command in the PostgreSQL configuration file, like it would be the postgresql.conf file or the auto.conf. Additionally, we can also set these parameters like recovery.target time to a time just before the table has been dropped. We can also mention the drop command as well with the recovery target name, but it depends on the level of vault set before. And we have recovery.target as immediate, which recovers the database to a prior consistent point, then all vault files exhausted. We can also add the action to be taken after the database restored to a point, like database will promote itself or pass the promotion using the recovery target action. The recovery.signal file will be removed once the database reaches a consistent state, right? So these are the commands that we need: the recovery target time, the recovery target name, and the recovery target action. Will tell the PostgreSQL what action should be taken after the recovery is completed. And we can start the PostgreSQL using the below command, and it will stop when the PostgreSQL database reaches to a consistent state, if we have mentioned in the postgresql.auto.conf with an option recovery.target action as pause. And that's how we can take the dump of the table that we have dropped previously, and we can restore that table into the production as a safe approach. So this is how the database full backups and incremental backups are taken using the PG base backup, a robust backup tool from PostgreSQL community. And we might be using the PG command backup to merge all the full backups and incremental backups to create a full restorable backup solution. And we also have wall archiving that can be enabled using the PG base backup.